So Chapter 1, Lesson 6 is going to be on function operations and compositions. One of the nice things about having function notations with your f's and your g's and everything is you can keep track of expressions or equations really easily. They're kind of like labels. This is like a name for this function. Instead of calling this function Doug or Amy or Sarah, we call this function f, and this is function g and function h and function k. We skip I and j because they can look kind of confusing. So if I was going to do f of x plus g of x right here, f of x plus g of x, that's really just, here's my f of x, and here's my g of x, and I put them together, and I get 3x minus 2x is x, 5 minus 12 is negative 7, and it's x minus 7. And this is actually the same as this. There's this kind of shorthand to just do f plus g of x, and this is saying the same thing that is saying. So this would also just be x minus 7. So here, g minus h of x really just means, g minus h of x really just means g of x minus h of x. So g of x is negative 2x minus 12. H of x is x squared minus 2x minus 6. And the important thing to recognize is I'm subtracting these. So since I'm subtracting them, I really strongly recommend you distribute this negative. So I'm going to write negative 2x minus 12 minus x squared plus 2x plus 6. Otherwise, lots of mistakes can happen. We're going to have negative x squared. The negative 2x and the positive 2x go to 0, so those are gone. Negative 12 plus 6 is negative 6. It's negative x squared minus 6. This would be the same thing up here. For f of x times g of x, this is where you have to do distributing, and some of you call this foiling. I'm going to do 3x plus 5 times negative 2x minus 12. 3x times negative 2x becomes negative 6x squared. 3x times negative 12 is negative 36x. 5 times negative 2x is negative 10x. Sorry, my handwriting is getting pretty poor. And 5 times negative 12 is positive 60. So it becomes negative 6x squared minus 46x plus 60, because these two combined in the middle. That's f times g of x. Those mean the same thing. So that's function addition, subtraction, multiplication. It's really pretty straightforward. You can also evaluate where instead of having x's, here I'm doing h plus k of x. Here I'm going to do h plus k of 3. This means I actually plug numbers in for x. So remember, this is really the same as having h of 3 plus k of 3. Well, I can find h of 3 pretty easy. H of 3 would be 9 minus 6 minus 6, which is 3. 9 minus 6 is 3 minus 6 is negative 3. So that's really going to become negative 3. And then k of 3 is also just negative 3. So it's negative 3 plus negative 3, which is negative 6. Or I can do h and k of negative 2, where I find h of negative 2 and k of negative 2 and put them together. But I want to show what's kind of a shortcut if you want to do a bunch of these problems. If you're just going to do one, this doesn't save you any time. But if you're going to do more than one, it probably does save you time. First, I could just find h plus k of x. H plus k of x would be x squared minus 2x minus 6 plus negative x. There's my two pieces. I put them together, and that becomes x squared minus 3x minus 6. This is h plus k of x. So now if I wanted to find h plus k of negative 2, I could just plug a negative 2 in over here. And I get 4 plus 6 minus 6, which is 4. Had I done it this way, where I find h of negative 2, h of negative 2 would become 4 plus 4 minus 6, which is negative 2. And this is negative 2, which is 2. I put those together and I get a 0, and that seems somehow off. No, sorry, 4 plus 4 is 8 minus 6 is positive 2. This is positive 2 plus 2, which gets you a 4. So this worked out to the same thing as this. In the same way, I could have taken this 3 and plugged it in here and done 3 squared minus 3 times 3 minus 6 which is 9 minus 9 minus 6, which is negative 6, which is the same thing I got the first time around. So the point I'm trying to make is you can either find h plus k of x first, and then just start plugging stuff into that new function, or you can do it in two separate pieces and put them together. I think if you're going to do multiple versions, like h plus k of 3 and h plus k of negative 2 and h plus k of 100, then doing one function first is going to save you time. But if you're just doing one, it doesn't really matter. We can also do this with mappings or tables or graphs instead of just with equations. Like here's my function f of x, here's my function g of x, and I can find f of 2 plus g of 2. Well, f of 2 I know is 0. G of 2 I know is 7. So 0 plus 7 gets me 7. F of negative 1 I know is 6. G of 3 I know is 8. So it's 6 plus 8 to get out of 14. And here I'm doing f plus g of 1, which is the same as f of 1 plus g of 1. We know that f of 1 is 2. We know that g of 1 is 8. And 2 plus 8 is 10. Good. What can be a bit more confusing for students is doing it from a graph. This is actually a fairly typical SAT, ACT type problem, although they often do it without numbers, frankly, and with letters, and we'll talk about that in class at some point. But here's a function f of x, and here's a function g of x. They both have graphs. They both pass the vertical line test. They both fail the horizontal line test. They're not one-to-one. That doesn't really matter right now. But remember, this axis here is all my inputs. And so this axis here gives all the outputs. So like if I wanted to find, before I do this problem, suppose I just said, what's g of negative 2? Well, that's my input. My input is negative 2, so I check the output. The output would be 1. Because if my input's negative 2, the output's 1, because it gives me the point negative 2, 1, because that's the point negative 2, 1. And if I asked, what is f of 5? Well, here, 5 is my input. It goes down to negative 2 as the output. So it's the point 5, negative 2. The output was negative 2. So f plus g of 5 is the same as doing f of 5 and g of 5. Well, we know that f of 5 was negative 2. We just found that. G of 5 is 3. So this works out to 1. If I want to do f times g of negative 2, I'm going to clear all this out now. F times g of negative 2. Well, f of negative 2 is 3. G of negative 2 is 1. So it's 3 times 1 to get out of 3. And then g minus f of 0. Well, g of 0 is negative 1. It's not that one. That's an open circle. Don't grab that one. It's this one. It's going to be 1 minus f of 0 is 3. So it's 1 minus 3 to get out negative 2. People start thinking this is like g minus f times 0. They're not being multiplied. It's function notation. We're doing g of 0 minus f of 0. Okay, so what about division? Division's a little bit weird. We've done addition, subtraction, multiplication. Division has some problems, though. And we'll talk about this a lot more later in the class. If I'm doing f of x divided by g of x, that can be written like this, or it can be written like this. It can be written any of those three ways. In fact, it can be written this way also. There's a whole bunch of ways to write division out. But it means the same thing. I'm taking f, and I'm putting it over g. But there's one consideration I have to worry about. In math, you're not allowed to divide by 0. So I have to ask myself the question, what value of x could possibly make the denominator equal 0? I just look at the denominator, not the numerator, just the denominator. What value of x could possibly make the denominator equal 0? In this case, it's the value of 6. If I were to do g of 6, I get out of 0. So in this function division here, I have to say x can't be 6. X can't be 6 because g of 6 is 0, and that would mean I was dividing by 0 on the bottom, and that's a problem. I'm not allowed to divide by 0, so when you have division, you have to worry about what the denominator can't be. What this means is if I were to find f over g of 6, I would get it undefined, because that would have me dividing by 0 at some point, and I'm not allowed to do that, and that's what this is saying. You just can't plug in a 6. So here, h of x over k of x would become x squared minus 2x minus 6 over negative x. Well, what can x not be here? X cannot be 0, because k of 0 is 0. If I was to do h over k of 0, I'd get out undefined. So x cannot be 0, because that means you're dividing by 0 on the bottom. That kind of confuses kids at first. But, sorry, I call you kids sometimes. For all I know, maybe you're 90 at this point watching on YouTube. If you're 90, maybe you're a kid at heart also. Way to go. Good for you. But that confuses people at first. You can't divide by 0, so figure what thing on the bottom makes this equal 0. The last thing to talk about is composition. It's putting one function into another. This open circle here, it looks like a times, but it means composition. Put something inside something else. We're going to call it of when we read it, f of. This is really, it looks like fog of x, but it's really f of g of x. F of g of x. What's happening is, I like to take that open circle and turn it into another parenthesis. We're really doing f of g of x. And I take the whole function g of x, the whole entire g of x, and I plug it in here. So it really becomes f of g of x. I go a little bit smaller. Is going to be 3 times, and this becomes 3 times g of x plus 5. This x right here just got replaced with the whole function g of x. So it's 3 times negative 2x minus 12, because g of x is negative 2x minus 12 plus 15. It's negative 6x minus 36 plus 15, which is negative 6x minus 21. And that's f of g of x, or f composed with g of x. The inner function is the one that goes into the outer function. So I'm going to take f of x and plug it into the h. I'm going to take this right here and plug it in for the h here, so it's really going to go to that x and to that x. There's 2 places. This problem's a little bit annoying, but it's worth seeing now. I'm going to do 3x plus 5 squared. You usually have x squared, but now the x became 3x plus 5. 3x plus 5 squared minus 2 times 3x plus 5 minus 6. So this function here now looks like this. This has to FOIL. Please don't just square the 3x and square the 5. You have to do 3x plus 5 times 3x plus 5. That's what it means to square. I'll simplify the rest. So it's 9x squared plus 15x plus 15x plus 25 minus 6x minus 16. I'll simplify a little more. So it's 9x squared plus 30x minus 6x is plus 24x. I just put all these together. And then I'll do 25 minus 16 is 9. That is h of f of x. Finally, h of f of negative 2. I have 2 options. One option is I've already found h of f of x. Since I've already found this, to do this, I could just plug a negative 2 in down here. Which becomes 36 minus 48, which is negative 12. Plus 9, which is negative 3. I could find it that way. It's negative 3. But the other option is first I could just find f of negative 2. F of negative 2 is going to be negative 6 plus 5, negative 1. Now I take this and I plug it into h. So I'll do h of negative 1. H of negative 1 is 1 plus 2 is 3, minus 6 is negative 3. I still get out the same negative 3 either way. So function composition is taking one function and plugging it into another one. One whole function replaces another one, and then you go from there. I think that's all we have for today. It is. Thank you.